Okay. Dividing a polynomial by a monomial. Mon meaning one term, polynomial meaning many. Now that we have had at least addition and subtraction with the same denominator, I can now kind of tie what we just did to monomial division, which is what monomial division actually is. So when you think about it, what you're going to do is you're going to divide by 4x squared. Now that's what that division looks like. Now you don't do a long division on this. Why? Because unless you know what you're doing, you're not going to end up with the same answer. But I want you to take a look at now, keeping in mind what we've done with same denominators, how I rewrite this. This is 8x to the 4th over 4x squared subtract 4x cubed over 4x squared. Now we've been adding and subtracting with same denominators. This is though what we have is a problem like we did last week. I have the same denominator, and then what do? Subtract the numerator, and that's what you have. It's kind of like unadding and unsubtracting using a monomial. I'm breaking it into two separate pieces. Now I reduce those two pieces. 4 divides 8 twice. I have 2 x's down there, 4 up there. So this is now going to give me a 2x squared because the denominator completely goes away. 4 divides 4. X squared takes out essentially 2 of those 3, leaving with a 1. And I'm going to have essentially just x. So my answer is x squared minus x. Now, if we had done the fraction part, I could say, suppose what I wanted to do is put this over a common denominator of 4x squared, and then I could create essentially the original, this problem right here. I could recreate it. But we're not going to do that because we haven't done that yet. But think about it. When you're doing monomial division, you're breaking it back up into an addition and subtraction problem, like we've done. Now I've got 3 terms, so this becomes 3x cubed y over 3xy plus 9x squared y over 3xy minus 3xy cubed over 3xy. Now again, if I were in what we did last week, I have a common denominator of 3xy, and if I want to put it over a common denominator of 3xy to make it a single fraction from 3 separate fractions, I would take 3x cubed y added to 9x squared y squared subtract 3xy cubed, and I would have the original problem. So it's kind of like you're unadding and subtracting, taking it back to its roots. Now I simplify. 3 divides 3, takes it out. X takes out 2 of those 3. The y's come out. So I'm left with just an x squared plus 3 divides 9 3 times. X squared, that gives me an x to the 1. Y squared, that gives me a y to the 1. So that says I've got 3x to the 1, y to the 1, minus 3 takes out the 3, x takes out the x, y takes out one of those 3, giving me a 2, and you're just left with y squared. Any questions?
I have one.
Mm-hmm.
If you take all the numerators and gather common elements.
But now you're not doing monomial division.
Oh, yeah.
You're
So
simplifying.
that's completely separate?
Completely separate, yeah.
Oh, yeah, oh, yeah, oh, yeah.
Yeah. What monomial division does is it takes something that is single term with multi-terms inside of it and divides it up into individual pieces. And then those pieces become workable. There are times when what you want to do is to factor and reduce.
Yeah.
But that's not monomial division.
Oh.
And the monomial division, so if I were in calculus and I needed to have something which is a clump, which is what this is, as one big monster thing, and get it down into 3 pieces I can work with, you'd use monomial division to do that. And by gathering the common factor out, right, I'd still have a clump. It would be a lower powered clump, but to still be a clump, I couldn't work with it individually.
All right. So don't factor when it's monomial
division, correct.
All right.
Would be nice, and it's tempting.
Yes.
But it's a completely different concept. I have 3 pieces and a negative 4x to the 4th y, so this is 8x to the 5th y divided by negative 4x to the 4th y plus 32x to the 4th y divided by negative 4x to the 4th y minus 16x cubed y squared divided by negative 4x to the 4th y. Whoops. Sorry about that. So negative 4 divides positive 8, negative 2 times. I have 4 x's in the denominator, 5 in the numerator. That gives me 1. And the y's go. So what I'm left with here is just 2x.
Wait, how'd you get positive 2x out of negative?
And it's supposed to be negative, right? Because the next one is going to be negative 4 into positive 32 is a negative 8, right? And the x to the 4's go, and the y's go. So that's going to be just a negative 8, a plus minus 8, minus negative 4 goes into positive 16, negative 4 times, 3 on the top and 4 on the bottom gives me 1 on the bottom. 1 on the bottom, 2 on the top gives me 1 on the top. But a negative and a negative creates a positive 4y in the numerator divided by x in the denominator. See, now I've got 3 separate clumps that I can work with individually that aren't as messy as that whole big clump. And that's the idea. It's a different form of simplification that makes it kind of useful to you.
So would it technically be in the 4x?
You can make it 4yx to the minus 1 if you wanted to. Is that where you're headed?
Yeah, like a negative x.
Sure.
Okay.
And depending upon what you're going to do with it, right, it would be fine, or you might have to write it and there are times in calculus, by the way, it would be fine to leave it as a negative exponent, but then if I'm doing something else, I've got to rewrite it as a positive exponent so that it needs to be where it's supposed to be instead of where it's not supposed to be. And it depends upon what you're going to do with it. But yeah, that would be an answer, and what she's saying is, could I write it this way? And the answer is yeah. Unless it says write your answer with only positive exponents. But that works just fine.
Now, I have a question.
Mm-hmm.
I'm confused at how the 4 came on top.
Because negative 4 divided into positive 16.
So
is
negative 4
-4.
would go over 1.
Mm-hmm.
And then negative switches its place, doesn't it?
Correct. So what I had was, we'll have a subtract, -4 or -16 divided by +4.
Oh,
Right.
because I missed the subtract in front.
Mhm.
Okay, yeah, now I understand. Okay, all right.
Yeah. Good to go?
Yeah.
Long division. Now, I could actually, this guy factors, and an x plus 5 would cancel out. Now, that would be your simplify,
Yeah.
but that's not divide. And you're going to find in college algebra, division serves a completely different purpose. Okay, so that says I want to take x subtract 5, or x add 5, divided into x squared plus 12x plus 35. Now remember how, this is where most of you fell apart, by the way. Not on choosing what you're going to multiply by, but what happens after you do it. I need to kill the x squared. So remember, I ask myself the question, what do I multiply x by to get x squared? What do I multiply x by to get x squared? You would say x, right? So that means this is an x. So you got there just fine. X times x is x squared. X times plus 5x is plus 5x. Then what do you do? Subtract. The subtraction changes all of the signs. That's so that the x squareds drop out. You have a plus 12 and a minus 5. That gives you a plus 7x. Then you bring down the next term. Some of you multiplied the x squared fine, but then you forgot to change the sign on the 5x. Everybody changes signs. And then you got down to here, then you didn't know what to do, and you fell all over yourself. What do I multiply x by to get 7x? This is now a positive 7x. So 7 times x is 7x. 7 times plus 5 is plus 35. And then you do what? Subtract. That changes the sign. And then plus 35 minus 35 is 0. So it divided evenly, so your answer is just x plus 7.
What are all those?
So it's a back and forth between the first integer or sign into the first
Term.
where you divide it,
Yes.
and then the second term times in what you got into the answer brought beneath the second term.
Because remember, the goal is, what division, long division is continuous subtraction, right? So the goal is, the squareds need to go away.
Yeah.
If the squareds go away, what you now have are x's to the 1 power.
Yeah.
So now you get rid of the x's to the 1 power. You've got to work it down until you end up with a number. That means that x to the 1 needs to go. So in order to make a 7x go away, this has to be a 7x underneath.
Yeah.
So that when you subtract, this becomes 0. And the 7x's drop out.
And then what you're left with is either the remainder
Is
or
the
nothing.
remainder, yeah. Remainder or nothing, right. I've taken a degree 2, moved it to a degree 1, down to a constant or degree 0. Because
So-
this is degree 1, your remainder's degree 0. Not 0 the number, but a number that any constant.
So it's x plus 5 times x plus times 7.
Is this guy.
Yeah, and you just keep bringing it down.
Correct.
So the subtraction sign, they're just saying numbers.
Yeah, and see what this does for me when I put those in, this tells me I've changed all the signs. So it forces me not to obliterate the sign that was there, because then I forget what the original problem was.
I just thought maybe.
I wrote it over top, and so that I know now, have I changed everybody? The answer is yes. The sign is circled. So that says it was originally plus, now it's a minus. Or if it's a minus, it became a plus. Everybody's gotten changed. Okay. Wasn't sure. You had that quizzical look on your face, and so it's like, okay. X minus 2. So I need to kill the 5x squared, because since this is degree 1, my remainder has to be a number, degree 0, constant. Unless I have a remainder that is a constant, I'm not done. So what do I multiply x by to get rid of 5x squared? You would be 5x. So 5x times x, 5x squared, 5x times minus 2, minus 10x, and now you do what? Subtract. That's a plus becomes a minus, that's a minus becomes a plus, and I've changed the signs so that the x squareds are now it's now gone. So minus 17 plus 10 is minus 7x. Then I bring down the plus 14. What do I...
The reason why we're not getting rid of x is because we're not multiplying, right?
We're not there yet. Which x are you talking about?
The 10x and 17x.
Because they're not the same number, they won't go away. I'm getting rid of the 7x now. I first had to get rid of the x squared, right?
Okay.
And then I have to get rid of the x.
Right.
So it's systematic. You get rid of degree 2, you get rid of degree 1, and then whatever's left over is your remainder. Now I say, what do I multiply x by to get 7x? And that would be not 7, but a negative 7. Because remember, when I change the sign, what happens? It's going to drop out. So negative 7 times x is negative 7x. Negative 7 times negative 2 is plus 14. And now I subtract, which changes the sign. So the minus changed to a plus, the plus changed to a minus. The x's dropped, which is what the goal is, but look what also happened. These dropped with a remainder of 0. It divided evenly. So my answer became 5x minus 7 with no remainder. Yes?